Hello guys, today we're going to take a look at this Fortuna tipping trailer. It's a Siku Control 32 trailer, and basically what we're going to try and figure out is how we're going to control this using one of our own tractors that doesn't use the Control 32 system. It's not using their circuitry, it's using our own circuitry. So how are we going to control that? So in the last video we discovered that there was two signals being generated on the last two wires of this connector, and when I looked into it on the oscilloscope I could see that one of them was like a clock signal and the other was our data signal. So maybe this is some sort of communications system or signal type that is common, but I just don't know enough about programming or communication between microchips to be able to identify what this is. But one thing I've noticed, I did look at a couple of things like I2C and a couple of different types of communications like that, and I noticed that they all seem to be normally high and the pulses went down. Even the clock signal was a negative pulse, we'll say. Well, it wasn't negative, it was going from VCC down to ground, or that's what it appeared to be to me, whereas this system seems to be the mirror opposite of that, or the polar opposite of that. It's always ground and then the signals go up. So I wonder, is it some sort of bit banging type thing that Siku have implemented themselves? But possibly it is some communication protocol that I'm just not aware of. But anyway, that's beside the point. Our signal is coming in 33 pulses of our clock signal, we say. So it starts with a smaller pulse, and then all of the rest of them are the same width. So the first pulse is 12 microseconds with a 24 microsecond gap, and then the rest are 32 microseconds with a 16 microsecond gap, and that is the same for the entire clock signal up to the 33rd pulse. On the data line we have the first pulse coming at the fourth clock pulse, so I'm including the short pulse in this. So the fourth clock pulse, we have our indicator, right indicator, on or off, and it's not turning the light on, it's telling the trailer that we want the right indicator to be flashing. So the trailer is doing the flashing and the signal is just telling it to start flashing. It's not giving it information to sync it with the tractor. So this pulse is telling it to turn on the right indicator, and this is a wider pulse. It's 42 microseconds with a 6 microsecond gap to the next pulse, and the reason for that is this clock signal is basically telling the chip that's receiving this data that it needs to read from the data at this point. So you need your data to be high before the clock so that when the chip reads it, it's definitely high, because if it was turning on at the same time, we'll say there's a possibility that the chip might read this voltage slightly lower than VCC, and maybe it would consider that to be a 0 rather than a 1. So you make sure that this pulse starts before your clock pulse, and that's why it ends up a little bit wider. So our first pulse on the data line corresponds to pulse 4 on the clock signal, and it's right indicator on. The next pulse, unsurprisingly, is for indicator left on, and by the way, the pulse goes high to turn it on, so it's normally ground and go high, and if you want it off, it's just ground the whole time. So it will just be a straight line here on the ground. So first one is indicator R, right indicator. The second one is left indicator. Then we move along our data line, and there's a pulse here which I'm not sure what it's doing. Maybe it's something that they don't utilize on this particular model. They might utilize it on a different model, but I couldn't figure out what it was doing on this. I don't think I even seen if it was changing. But the following pulse then, which is correlated to pulse 9 on the clock signal, is to turn on the tail lights. So the tail lights is either a pulse for on or off at clock signal 9. Then we have a couple more pulses here that I wasn't able to identify coming on clock signal 12, 13, 15 and 16, so not sure what they are for, but they were high on my system anyway. Maybe they're used on one of the other models, not sure. Then when we get round to 19 on the clock signal, then we start to see the bits of our axes controls. So our y-axis control, that's the next 8 pulses. So 0, 1, 2, 3, 4, 5, 6, 7. That's 8 pulses, or 8 bits of the byte that represents the y-axis on the controller. And the first one is the least significant bit, and that moves up to the most significant bit at clock pulse 26. Then from clock pulse 27 to pulse 33 are our x-axis controls, but we've one less bit for this for some reason, so we've only 7 bits from 0, 1, 2, 3, 4, 5, 6, and that's given your x-axis control. And again, starting with the least significant bit at clock pulse 27 and the most significant bit at clock pulse 33. That is as much as I was able to figure out of the code anyway. So now we need to recreate that in a chip that will convert from my system, my RC tractor, to the system that this controller is using, because we don't want to modify the trailer. We want to figure out how can we use it in this system. In last week's video you seen me working with these little boards. I was trying to get them, well, they were supposed to be the new control board, but like I said, the voltage regulator seemed to be a bit of an issue, and so did the capacitor on the NRF module. So they didn't really work the way I wanted them for controlling a tractor, but the little board itself worked perfectly. So what I did was set one of them up here to be the kind of interpreter between my system and the Siku Control system. You see, I hadn't intended to do this, so what I have here is the RX line. So that's the receive line for this chip. It's going to be connected to the TX line on my tractor, because that's how I've always done it. There's a transmit line, and the tractor transmits back to the trailers. Normally in my trailer it would be something along the lines of this. You'd have a controller that was going to control the trailer, whether it's a motor or a servo or whatever. It's going to connect it to that, and to do that you'd have these 3 lines, so a ground, a positive, and a signal line, so a receive line on this case. And normally in my tractors the battery could just be, you can either power the trailer from the tractor or power the tractor from the trailer, and normally I'd power the tractor from the trailer because I can put a much bigger battery on the trailer. Now, instead of hooking a servo or a motor or whatever it is up to this to control or to set it up in a trailer, what I've done is add these 4 lines, which are going to connect to our Control 32 trailer. So we have our ground and positive again, but we have the 2 signal lines that I'm going to use to bit bang that data through. So the one of these wires is going to be the clock signal, and the other is going to be the data signal. So I'm going to be able to hook that up to my kind of modified battery that I had here. So if you remember, I had it kind of wedged in there. So there's my modified battery, and this little cable is just connected to the contacts on the battery. So that's going to wire into this little board, and we should be able to control our tractor from that then. Okay, here's our little board that we're after programming, and we're hooked up here to the ground and the positive line on the tractor, and the TX line, so the transmit line from the Atmega chip. And that's going to our little board here where we're running our code that converts that signal into the one that the Siku trailer can understand. So because I needed those wires exposed, I'm still using this battery pack here, but we have this battery here to simulate the battery that's inside the normal Siku battery pack, and then we have our connection here, which is the 2 middle wires, which is connecting to the battery inside the tractor here, and then we have our signal wires coming in here on the final 2 pins, just like you get inside the battery. So we have our controller here. This control is usually what we use for the trailers whenever I've made my own trailers, so obviously I'm going to use it to control this trailer too. And maybe you can see the little line down there that indicates the point what we're at, so the angle that we're tipping, I guess. So if I move this control, we should see that line move and the trailer tip. So that's clearly working. If we turn our lights on, so let's just throw all the lights on, and you can see our tail lights are on here now. If we turn them off, hit our indicator. Now the only issue here is when I make the trailer, I get a clear signal back from the controller I've put on the tractor to the controller I have in the trailer, which means that the signal for the indicator on the tractor is going to exactly match the trailer signal, because it is the tractor that's controlling the trailer signal. There's no timer in my trailer that's going to simulate the light. So when I send the signal back, it just turns on the light in the trailer, and when this says turn off, it just turns off the light. There's no timing going on in one of my trailers. But in this trailer, the Siku trailer, what happens is they send a signal which tells it to start indicating. So that means that unlike one of my normal trailers, this indicating is out of sync with the tractor. It's not being controlled by the tractor. The tractor's just saying start indicating on the right. But at least it's turning on the right side. So if the right indicator is happening here on the tractor, don't know if you can see that. Yeah, you can see it. It's a little slow for some reason, but it's indicating anyway, and that's the right there. And if we put on our hazards, so you can see on the controller our hazards are on, and on the trailer our hazards are on. So all of those functions seem to be working fine. Alright, so we figured out how to control the Control 32 trailers from our tractors, but what if we want to control a trailer that we've made from our Control 32 tractor? So that's what I'm going to try and do in the next video. We have our Fendt 930 and we still have the control board from the John Deere 6920S, so we should be able to hook up some system to control one of our trailers. For example, the baler that we have, the John Deere baler, should be able to control that from the John Deere, although possibly the Control 32 controller doesn't have enough functionality to do that, but we'll work some way of getting it to work for us. It won't be that difficult, I don't think. So if you liked that video, make sure and hit the thumbs up, and if you have any comments, let me know below the video. And that's pretty much everything, so thanks very much for watching.